This section is all about how to find angle measurements in triangles. First thing we'll discuss is the type of angles that we see surrounding and inside our triangle. Our first set of angles we're going to be seeing are our interior angles, and these are angles that are inside our triangle. So we are looking right here, here, and here. Our exterior angles, these are angles that are adjacent to the interior angles or on the outside. So that would be anything here, here, or here. So notice that these angles are created because one of the sides of my triangle is extended. Okay, so the line from B to A is extended, and now we're seeing that angle that is formed along the outside edges of that triangle. Okay. And the last thing we'll discuss here is corollary. So a corollary is a statement that can be proved easily using theorems. Okay. So let's take a look at our different theorems that we're going to see in this section. So our first theorem, this is one that we've already discussed, is our triangle sum theorem. So this means the sum of the measure of our interior angles of a triangle is always 180 degrees. Okay, so if I take the measure of angle S, U, and M, in total, I will get 180. We will use this one a lot, so I want you to start that one. Another one we're going to see is a corollary to that triangle sum theorem. So let's say you have a right triangle. Okay, I have this little box here. If you have a right triangle, and you can see that because that box is there, it means that your two acute angles that are left over, so I and G, are complementary. And if you think about it, you have 180 degrees total in your triangle. If you know that you already have a right angle that's in there, that leaves 90 degrees left to be split between those two smaller acute angles. Now, from here, we're going to go through and we're going to do some discovery with finding missing angle measurements. That's going to be our key goal for today. So I discussed earlier, these are examples of your exterior angles. Okay, so notice how you have one of your sides is extended, and with that you can see that this angle right here is now created with those two adjacent sides. These are not exterior angles. So notice how here, yes, this looks like it's extended, but it's not a straight line. There is some curvature there. Same thing here. This is not an exterior angle, nor is this one, because we're not seeing that straight line. Right? All I want to do is try to find missing angle measurements in the figure, and I do want you to then record them on the table below. We're going to create a nice little research page, and this is going to be something that you can look back on. And really what I want you to do is look for some type of pattern in the relationship between the measure of angle BCD and the sum of the measures of angles A and B. We'll talk about that after we go through. I want you to be keeping notice of that pattern. So we're going to calculate some missing measurements here. Now, in total, we know a triangle should add up to 180 degrees. I'm still looking for the measure of angle A here. Don't know what this one is. And I also need to know what angle ACB is equal to. So I want you to think about things that you know that we've discussed so far in this class. What are some missing things that we can figure out? I'm hoping that this relationship right here stands out to you. Now, we see this forms a straight line. So if I have a straight line here, we have a linear pair. If this angle is 56 degrees, that means this missing angle here has to be 124, because I know that my linear pair has to also add up to 180 degrees. All right, so now I have two of my known angles and one over here that is still missing. So if I take the 180, I subtract 20 from it, and I also subtract 124 from it, I would be left with 36 degrees. And that's what I'm seeing for this angle right here, 36 degrees. Okay, So I'm going to fill some stuff in. Alrighty, so figure 1, scroll down here. Measure of angle A, we said was 36 degrees. Measure of angle B was 20. And the measure of angle ACB, that was my obtuse angle right here, that was 124. Alrighty, and BCD, that was that angle along the outside here, that exterior angle. That one was 56 degrees. The last little part here, I want to just add together the measure of angle A and the measure of angle B. So if I add those two together, that would be 36 plus 20 would give me a total of 56 degrees. Okay. Keep that in mind. Let's look at our second one. Figure number 2. Now, I know right away that little box here, 90 degrees. Alrighty, I see this is 33. So if you think back to our previous page, we talked about our corollary to the triangle sum. So if we have a right angle, that means our other two angles have to add up to 90. So if this is 33 degrees, that means this angle up here has to be 57 if these two angles have to add to 90. And then once again, I'm noticing here I have my linear pair. If this is 33, this would have to be 147 degrees for them to add up to 180. Let's go back down here. Figure number 2. Angle A was our right angle, so that was 90 degrees. B, that was the one that was there, 57. ACB was 33 degrees. BCD, that was that exterior angle, we said was 147. Now let's go through again, adding up A and B. I would get 90 plus 57 is equal to 147. Alrighty. Continue to keep that in mind. We have 2 more figures to go. Hopefully by now you're starting to catch on to what our little pattern is. Okay, 55 and 27, which means in order for them to total up to 180 degrees, this angle here would have to be 98. Oh my goodness, 98. And then once again, you know you have a linear pair that adds to 180, which means that we have an acute angle over here of 82 degrees. All right, so let's continue to fill out the chart. A we said was 55. B was 27. ACB, okay, that was our obtuse angle here, 98 degrees. BCD was our exterior angle, that was 82. And once again, let's go through. A plus B, we have 55 plus 27. What does that equal? 82. Okay, by now I'm really hoping it's starting to become pretty obvious what that pattern is. All right, we got one more. 21, we have our exterior angle here is 136. Once again, we know these form a linear pair. They have to add up to 180, which means this angle here has to be 44 degrees. And then we already have 21 and 44. That gives me 65 degrees. So 180 minus 65 leaves me with 115. And that's our last angle here. So let's finish filling out the chart. Angle for figure 4, angle A, 115 degrees. Angle B was 21. ACB, 44 degrees. BCD was that exterior angle, that was 136. And then lastly, I'll go through. We're adding together 115 and 21. That gives us 136. Alrighty, I'm going to go through. I'm going to take away some of these highlights here. And we're going to really just, hopefully, hit home what we're seeing here. So this is 57. My apologies. take away these highlights. And now I'm just going to notice here, 56, 56, 147, 147, 82, 82, 136, 136. All right, so this discovery leads us to our exterior angle theorem. This states that the measure of an exterior angle of a triangle, so if I look at angle 1 here, that is equal to the sum of the measures of the two non-adjacent interior angles, so angles A and B. So if I were to add those two together, as you saw in those 4 previous figures, that gives me the measure of my exterior angle. Okay, so if I look here, let's keep in mind, I'm going to kind of skip figure 1 for right now. This one, I don't think necessarily uses that, but let's focus on number 2. Here's my exterior angle of 56 degrees. Okay, I know this is 20, so that means if I take 56 minus 20, I would get 36 degrees, which is this angle here. If I look here, if I throw some algebra into that, there is a relationship between these 3 angles. That 2x minus 8 would be equal to the sum of my 2 interior angles. And then I could go through and solve for x. So I would add 8 to the other side, subtract the x. This would give me x is equal to 39. Not degrees, just 39. Okay. All right. Now I could go through here and do a little bit more. These are just finding missing angles. I think this is a good idea. The scavenger hunt that you will be working on the next 2 days elevates this. So let's go through and do some of these together. I see this is 90. This is 42. Once again, your total is up to 180. So that means if I take 90 plus 42, that's 132. 180 minus 132 would be 48 degrees. Next one, we've talked about this before. These are our 2 non-adjacent interior angles. There's your exterior, so 7x plus 1 plus 38 equals 10x plus 9. Let's combine like terms here. 7x plus 39 equals 10x plus 9. I'm going to get my variables over to the right, get my constants over to the left. I would get 30 is equal to 3x, which means that x would be 10. Now, missing angles, so plug 10 back in. That would mean this angle here, 10 times 7 is 70, plus 1 makes this 71. And this angle here, 71 plus 38 would give me 109 degrees. Okay. This one over here is similar. 180 minus 58 minus 64 give me, I need to pull out my calculator for this one. 180 minus 58 minus 64 would leave me with 58 degrees. Which means we actually have an isosceles triangle. Very cool. Acute isosceles, actually. All right, I'll look at this next one. Once again, sum of your 2 interior angles that are non-adjacent totals to your exterior angle. So x plus 65 would be equal to 2x plus 10. Subtract the 10 over, subtract the x over. We get that x is equal to 55. This would be 55 degrees. And then 55 plus 65 over here would give me 120 degrees. All right, you get the idea. Now I do want to talk about these last 3 over here because I think the concepts that they bring about are a little elevated and I think they'll be helpful. So let's look here. A few different things you can do with this triangle, and I'm actually going to zoom in a little bit so we can put more of a focus on it. If it lets me scroll over, it might not. There we go. Okay. So here, 180